Good morning. I wanted to talk a little bit about the Hermits Epidemic. Obviously, this is a probability task, if you will. Essentially, what I'm asking you to do, now you can work together with other people, but the deal is you're all going to submit your own document, right? So work on it separately, but you're going to be kind of discussing it all together, right? So you can kind of all have you can all help each other out, right? I wanted to kind of go over it a little bit and give you some tips so that you can kind of figure out what's going on. So here we go. The Hermits Epidemic is essentially a way to kind of talk about probability. I always do this every year. This seems a little bit more appropriate this year for obvious reasons. You've got 6 people that live on a deserted island, okay? Now these people normally are very social, but unfortunately an infectious disease has landed on the island, and the disease is infectious for only 24 hours, okay? The rule is that each hermit will visit another hermit only once a day. And once that 24 hours has happened, the hermit that is infected becomes immune to the disease, so you can't get it twice, right? So if you visit the same person twice, they can't get the disease more than one time, okay? Essentially what's going to happen is we'd like to know the probabilities of the different hermits getting infected, right? 1 person or 2 people or 3 people. What you do know is that 1 person 100% gets infected, right? That's guaranteed to happen. And from that point on, it's kind of like, well, let's see what would happen. So the questions you're going to answer is, what's the least number of hermits that could get infected, right? For example, if the first hermit who's infected is going to go to visit another hermit, definitely, right? So you know that you're going to have at least 2 people to get infected. That's the minimum number that's going to get infected. All right, and the greatest number, I'll let you guys kind of think about that one. What sort of model? I'm going to give you a clue here. You can be infected or not, right? And so you've got a scenario here that a tree diagram is really going to work out well to help you with. And you're going to kind of have to figure out if you get immunity, then the disease dies out. If you don't, then the disease continues to spread. So keep in mind how that will work. I want you to do 2 things. Number 1, I want you to simulate it using either a random number table or your calculator random number generator. Okay, you can find a number table either searching online. You can use the one in the back of your textbook. You can use just your calculator's random number table. You need to set this up. You may need to go back to chapter 11. The Toy Story Lab is kind of where we started to learn all about all this. And you're going to have to think about this one, right? How can you do it? I also want you to do this analytically. I want you to actually, since we know how to do probability now, I would like for you to work out the theoretical probability of all 6 hermits getting infected. I also would like you to figure out, on average, how many people would you expect to get infected? That's question number 5, right? Not every hermit's going to get infected every time, right? We'll know the probabilities of all those things happening, but the question is, on average, and in chapter 16, that's one of the things we're talking about is expected value. And if you don't know what expected value is, well, look it up. We're going to talk about it tomorrow, but expected value is very similar to the average. If you want to get a short summary, you can kind of go to this week's weekly overview. I'll give you a summary about it and kind of tell you how to calculate it. The thing you're going to need to do with this is make a tree diagram and work out the probabilities. The question is, you're counting the number of people that will get infected, right? Obviously, we know that 2 people and more could get infected. Obviously, all the way up to all 6 getting infected. I'd like for you to work out those probabilities, talk about it amongst your group. If you've got any questions, please feel free to let me know. We're going to be working in groups today kind of individually, just like you would be if you were at home. You can kind of talk with your groups, make FaceTimes or Google Meets or however you guys want to work that out. If you have any questions, let me know and I'll be happy to help out.